So this is about the Misha Mahowald Prize in Neuromorphic Engineering. I'm going to first tell you something about why we founded this prize, why Rodney and Conan and I decided to form this prize in the first place, and a little bit about the history of neuromorphic engineering. And then I'm going to try to play you a video so you can hear Misha in her own words. And then I'll tell you about the awards this year of the Misha Mahowald Prize for Neuromorphic Engineering and the Mahowald Early Career Award winners. So here are Carver, Mead, and Misha Mahowald at Caltech circa 1993 or so, 1990, looking at one of the Keithley instruments. At that time, Carver had started teaching a class with Dick Feynman and John Hoffield on the physics of computation. And I have a clear memory of sitting down in the basement of Jorgensen in this class. There was literally only about a dozen students. We had Hoffield or Feynman or Carver teaching the class. And here was this fellow who's talking about, I heard about neural networks by then a little bit. Here's this guy talking about transistors. I said, why is he talking about all these old transistors, man? That stuff is so old. So, but anyway, at that time, Misha was the TA for the class, and she was a young biology student, didn't know a thing about electronics, transistors, semiconductors. But she took the class and started working with Carver, and she was the one who had the idea, let's do a silicon retina, because at that point, Carver was doing more abstract things like neurons. And so she and Carver teamed up together, and as part of a PhD work on the original silicon retinas, they got the cover of Scientific American. How many people don't know Scientific American? Okay, so it's a popular science magazine, very good magazine for many, many years. And this is Misha's cat, which he captured after several days of work, recorded directly with a photo from the screen of a multi-sync monitor, which was displaying in a scanned way the output of her silicon retina. And you can see the kind of high-pass filtering characteristics in space and time here in this picture. But this is the first of Misha's interlocked PhD projects. So just the very first. And later, together with Rodney Douglas, they did the work on a silicon neuron, not just a silicon neuron, but a true Hodgkin-Huxley model of a silicon neuron with all the different currents and time constants. And I remember Rodney had built, with great pride, Rodney, you're there,
Yeah.
with little potentiometers, POTS, from whence comes the name Best Pot Smoker Award here in Telluride. And you can adjust these potentiometers, you can adjust the characteristics of this Hodgkin-Huxley neuron and just play with it in real time on an oscilloscope. It was a beautiful board. And this got the cover of Nature. A very quite simple circuit, which fits in a schematic on one page, built out of transconductance amplifiers and capacitors, essentially, and some nonlinearities. But that was just the second of Misha's projects. Actually, Misha's thesis award was well-deserved, won the Clauser Award, the same one that John's student won a couple of years ago or last year in 1993 for the best overall PhD thesis. If you get out your phone right now and you can scan this QR code and you can come straight to her thesis. It's really a beautiful piece of work. And it uses the silicon retina, it uses silicon neurons, but it really works on a stereo vision system, which I don't have time to tell you about. But in the stereo chip, which would do fusion between two one-dimensional retinas, one-dimensional projections of a retina, Misha had incorporated electronic models of different classes of cells that are observed in cortex, tuned excitatory, near and far cells, tuned inhibitory, and monocular cells. You know what? These are cells that respond to only input from one eye. And this is a little puzzle for you. What use would a binocular cell be in stereo vision? Somebody who doesn't know the answer.
Disparity.
Yeah, but for what in particular?
Depth.
Depth, right? A depth discontinuity. Because if you have a depth discontinuity, you see stuff in one eye and not the other. And so that's where you break the disparity. This beautiful chip, which I can't describe, it mixed together population codes, cooperation, competition, smoothing, and all this beautiful stuff, all in one beautiful chip. And so that's really what you got the PhD award for. I think still a beautiful piece of work. And so I now want to try to play you a video.
somebody took me to the coffee house, and it was full of comic books. And there was scribbling all over the halls of one of the dorms done in fantastic colored marker. And I thought, this is where I belong. And what I found was that it was quite difficult to interact with them as peers. And in fact, it was almost as if we were playing some kind of game, like a basketball game. And when I got onto the court and got the ball, everybody stepped back from the basket, and I threw the basket, and the game went on as before, as if nothing had happened. And I found that extremely confusing. What I find is if you keep silent as a woman, people assume that you're a fool. Whereas if you keep silent as a man, people assume that you're not. I'm hoping that we will come up with a set of experiments that wind up shedding light on how the brain really works based on our experiences in the silicon medium. This hasn't happened yet, and I think that it needs to happen before the biological community will look seriously enough at the silicon work to learn from it. Stereo is an interesting problem because it's something that happens in the brain. By the time you get into cortex, you see a lot of activity resulting from the cortex itself. The brain is imagination. And that was exciting to me. I wanted to start building a chip that could imagine something. And stereo is the first and simplest problem where it's very clear that something is being imagined. There were 3 different video monitors that were used, one for each eye and one for the stereoscopic depth computation, oscilloscopes, power supplies, voltage meters, 2 large tables full of equipment with blinking lights, and then the chips that I had built myself, which were by and large held together with wire tied in random places on the proto board and sort of loose ends hanging off every which direction. One of my retina chips was quite touchy. The design wasn't ideal, and if you apply the wrong voltages to the chip, it has a tendency to latch up, which means it gets very hot. Sometimes it melts. It's a bad thing. And these chips were so delicate that even though they had sent me 20-odd copies of the chip, I only had 2 left. And I needed 2 to do the demonstration because I was doing a binocular stereo demonstration. And I turned the power supply on, and there was a loose wire. The chip got really hot, and I thought, oh no, I've ruined it. This is the last chip, and it's never going to come alive again. But I took it out, let it cool down, put it back in, and it was fine. But it was the most harrowing moment. Your heart just pounds.
Okay, so in 2016, based on our knowledge of Misha, who later suffered terrible mental illness, depression, schizophrenia, just kept getting worse and worse. She just couldn't take it anymore after some time. So, but in memory of Misha and her work together with Carver to establish this whole field of neuromorphic electronic engineering, in 2016, we established the Misha Mahowald Prize, the MMP, whose goal is to recognize outstanding research in neuromorphic engineering. And the award is $10,000 for that, and it usually goes to a large group of people. So a scientific research group for work that spans a number of years. In 2021, recognizing that this excluded many students just like Misha, who had just finished their PhD, we established the Misha Early Career Award, or the MECA, and it recognizes an exceptionally talented individual student like Misha Mahowald or anybody else that does beautiful work during their PhD. I highly recommend, I'll tell you at the end, that you have to look carefully at the rules. The award is $2,000 cash plus participation in either this workshop or Kapakacha workshop. Or I suppose we should also now in the future include the Bangalore workshop, right, Andre? Okay, Andre's not there.
Yeah, I agree. I just muted.
Yeah, thank you. And so we've had the service of a number of really great juries and sponsors over the history of this award. The jury for the MMP Prize in 2025 is Steve Ferber, Mitra Hartman at Northwestern, Shichi Liu, who is right here, Dharmendra Mota at IBM Almaden, Eric Ryu, who is online there. I don't know if you can show yourself. Yeah. Also Hava Siegelman at Amherst, and Terry Sanofsky at the Salk Institute, who chaired the selection committee. So as organized, we have no say in who gets the award. It's the jury that finally comes to a consensus about who should receive the award from the submissions that year. And for the MECA jury this year, we had Munya, who was here earlier during the workshop, Emre, who is right here in the room, I think, or has he left already? Oh yeah, Emre is right here in the front. And Andre von Schaik, who is in the UK right now. This is outdated, by the way, right, Andre? You're now at Manchester University.
Correct.
Where Steve was before. So move this University of Manchester or copy it down here. And Andre chaired the MECA jury this year. And the award has been sponsored over the years by Any Labs, the company I told you about earlier, Innovation, SynSense, and the Neurotech Initiative. And we're interested in sponsorship if you'd like to help sponsor this award. So the past awards, I want to just quickly go over these because they should be instructive about what kind of work this has been recognized. The first award went to the IBM True North project from the Darmendris team at IBM Almaden. The second award went to Davide Scaramucci's team at the University of Zurich for event-based vision for their drones. In 2019, the award went to Greg Cohen and his team. Where are you, Greg? Yes, there you are. For the Astrocytes, a mobile neuromorphic space situational awareness observatory. You guys know about this beautiful observatory sitting in a container, a shipping container, where the roof can be retracted and a set of telescopes lifts up? Yeah, it's really cool. And 2020, the award went to Shichi's team working on silicon cochleas, hearing with silicon cochleas. Also at that same time, because Karl-Heinz Meyer died, we had awarded him a Lifetime Contribution Award for his contribution to neuromorphic engineering through all the big wafer scale chip projects. And then in 2021, the award went to Ed Laylor and team. In fact, Malcolm is part of that team. Anybody else was part of that team here? Shihab, yeah, for auditory attention decoding from EEG signals, and simultaneously, or with equal credit, to the project of the Silvestro Masira team from EPFL for computer-brain interface that restores lost extremity sensations. And in 2022, the award went to the neuromorphic eDermis for restoring complex touch from the Nitish Thakur's team from Johns Hopkins. And at the same time, the first MECA award went to Chang Gao, who was a participant here in Telluride a couple of years ago for his work on hardware recurrent neural networks and their applications. And in 2023, finally, we made a long delayed reward to Carver Mead himself for a Lifetime Contribution Award. We did that at the NICE conference, the NICE conference in La Jolla. And Carver gave a wonderful talk after that. And the MMP award went to the team from Sandia for their project on neuromorphic advantage for discrete time Markov chain random walks. So that's kind of a history of the kind of awards that we had. So we had only one MECA award so far, right? The other times there were submissions for the MECA, but the juries did not deem them sufficiently distinctive or worthy of recognition. That year, perhaps they had some technical flaw. Okay, so let me tell you now about the 2025 prizes. And the 2025 Misha Mahowald Prize goes to a team from UC Santa Barbara for this project, Stochastic Neuromorphic Computing with Probabilistic Bits. I'm going to say a bit more about this project and then ask that team to show themselves and say a bit about this award. But the team is right here. It's Navid, who is online, I think, Shuvro, Shaila, Kemal, Nihal, and Karam. And Karam here is the PI of that team. And the jury citation is that the Orchestrating Physics for Unconventional Systems, or OPUS lab, implemented an architecture with special purpose digital hardware, actually mixed signal hardware, based on three neuromorphic principles: massive parallelism, asynchronous dynamics, and sparsity, and demonstrated applications to problems in combinatorial optimization, energy-based machine learning, and quantum simulations. And in particular, they did three different stages of implementation of this. They did a mixed signal implementation with between 5 and 15 of these stochastic probabilistic bits demonstrated in the hardware shown here, which allowed them to build a system with microsecond time or 1 million flips per second per analog p bit. And it reported in this paper. And then they also demonstrated an all digital single FPGA implementation with between 2,000 and 10,000 digital probabilistic bits on this FPGA board that was capable of up to 150 billion flips a second. It offers over 10 or 15x speed up over GPU and TPUs. And they showed the application of this for machine learning in this paper and for optimization problems in this paper. And finally, they showed up and are currently working on, I'm not sure what the publications say to this, but perhaps I can say, it's a multi-FPGA system, illustrated here. And they're aiming for a 5x scale up with no errors and sparse graphs. And so now I'd like to invite the team to come on to the stage here. So Karam, are you there?
Yeah, I'm here, Toby. Thank you.
Can you guys hear in the audience okay? Okay. Would you like to say some words about this award?
Yeah, thank you very much for that summary. It's really great. Yeah, it's mixed signal and digital work, and I'd like to thank the jury. We are extremely honored for this recognition of our work, and I'm very proud of it to win with my students. Because it's, as you can see, it's a multiple students, multiple papers, and they're all co-authored this. They've contributed greatly, and it's just we're extremely honored. Thank you.
Thank you. What are you guys up to now? What happened with this multi-FPGA system? Which direction are you going?
So we're scaling it up. So that paper isn't in print, unfortunately, still. So the first author, Navid, is doing an internship with Siemens. And actually, he was telling me that he's helping their multi-FPGA emulators and he's debugging it with them. But we are very excited. It is not a thing of the past. We are doing digital and mixed signal scale up. And so it's we're all very active. It's still, everyone that you're seeing in this award are currently doing their PhDs. Navid is my a graduate student. He's the most senior among the team. He's graduating. Dr. Shuvro Chaudhary is a postdoc. He's trying to push on the quantum angle, how much of quantum applications really require quantum computers. So that's the thing that he's doing. And Shaila, Kemal, and Nihal are all trying to push this forward and writing first author papers in their respective areas. So we're still very excited, and we think it's still very interesting.
And I want to go on to the next award on this other computer, which is the MECA Award. So this is the Misha Early Career Award. And this year the jury had the pleasure of jointly awarding the MECA Award to Jens Pederson for the neuromorphic intermediate representation and to Mark Iskarous for invariant neuromorphic representation of tactile stimuli to improve robustness of a real-time texture classification system. And here is Jens, actually here at the workshop in 2023, expounding his ideas. You'll see a picture later. And here is Mark from the headshot picture. So I'm going to start with Jens's neuromorphic intermediate representation. Jens is now at the Neuromorphic Systems Lab at KTH in Stockholm. I think it's Jörg Conrad's lab. And this work was conceived at the 2023 Telluride workshop and subsequently developed by the community led by Jens. And the jury citation is that the neuromorphic intermediate representation is an important effort to lower the barrier of entry to using neuromorphic computing hardware by providing a standardized set of computational primitives. This effort will allow many more researchers to use and try out neuromorphic hardware, which in turn we expect will lead to advances in neuromorphic computation and neuromorphic hardware. And so here is actually the conception of the project from the 2023 workshop. You can see people like Steve, Gregor is not here, Felix is not here, and Jason is here. I don't know, is Jason here right now in the room? Okay, but he's still at the workshop. Did he leave today?
Jason is here.
He's here, but not in the room. He's trying to finish his project. Yeah. And they have a lovely website, neuroir.org. It has a lovely landing page like this. You click on that and you come to all kinds of useful information, how to use the code and what's the motivation for it. The idea is to interface, if I may speak for you, Steve, and Jens, between hardware, basically the same way as ONNX does for mainstream DNS. Basically to provide a bridge between these different platforms, command line tools to convert between representations. And it's very active. It's downloaded 5,000 times a month. And it's been steadily developed since 2023. Here is the commit history. And the top committers are obviously Jens and Steve also, but there's a long list of other people that have contributed to this over this period from July 23 all the way up to now. So it's really a live project, wonderful project. So I would like to ask Jens to come on screen if possible. Yeah, there you are. And say a few words about this. Let me just go back to the award page, the award, so we can get a nice screenshot.
Say a few words so you can capture me mid-speech. That's typically the best pictures. No, but I'm first of all very, very honored to be put in this excellent company. I mean, it's incredibly motivating as a young researcher to be given this honor. And I also want to thank the recognition of this kind of work. I think it's really important that we think about these kind of reproducibility problems and the barrier to entry. We as the co-authors really agree that that's a necessary step for the community to grow as well, and for the science to proliferate. So thank you so much. Finally, I just want to say that it's really a team effort. The picture you showed of me is actually cropped out of a longer picture that you also saw with all the names, and that's really how this started. This could not have happened if it were not for places like Telluride, the workshop where we could gather together and discuss ideas freely. It's a very, very unique environment. So this would not have happened without Telluride. Thank you so much for that. And then finally, let me just mention Steve Abreu, who's like an equal contributor on the paper, who championed this, and of course Jason for all their help. So thanks everyone. I really appreciate this.
Okay, so now let me go to the second award. Again, fiddling around here. To Mark for his project Invariant Neuromorphic Representations of the Tactile Stimuli to improve robustness of a real-time texture classification system. Mark is now a postdoc at the Sensory Motor Bionics Lab at the University of Chicago, but I believe the bulk of this work was actually carried out in Nikhil Thakur's lab at Johns Hopkins. And the jury citation from Andre and Emre and Munya for this work is that this application impressed the jury because it combined neural modeling with hardware and experimental testing in a sensory domain that has so far been less explored in neuromorphic engineering. The work creates a force and speed invariant representation of texture, which you'll see in a video in a moment, that improves accuracy and computational efficiency of texture classification, which is tested in real-world experiments. And so now, taking from their prize submission and the webpage, I have a video.
Yeah, so this is the system diagram for the real-time system. We have a motion tracker with Vive, and then we have our microcontroller taking in the information, converting it to spikes, and then doing classification. And so we're showing the velocity trace and showing basically that it'll classify the texture even as the velocity profile changes. So this is the speed invariance that we try to implement.
And so here you have a normal circular ridges, scanning speed fast, and you can classify that as that texture type. This video is too quick to understand it, but you can go take a look at it on the website. So Mark, would you like to say a few words now?
Thank you. Like Jens said, I'm very honored by the award, and this is not a traditional, I'd say, neuromorphic paper or project, but so I feel very appreciated that it's not as theory oriented. It combines a little bit of biological inspiration, hardware, and then real world implementation, and that was recognized. So that is very nice of the committee. There are a lot of people to thank. The neuromorphic community has been great for me over the last few years. I attended the Ningo workshop in 2019. I was at Telluride in 2022. Last year, I went to INI because of the NeuroPac fellowship to work with Elisa Donati and Giacomo Indiveri. And then at Hopkins, in my PhD world, I was surrounded by Ernst, who I think is in the room there, and Ralph Etienne Cummings, and of course my advisor Nitish. So the neuromorphic community has been around and been very supportive in my projects. And then in terms of the project itself, I want to thank Zan and Fangji, who were undergrads that are now both PhD students, and they were the ones who helped collect the data and build the robot for our offline version of the system. And then Sam, who's a PhD student in the Decor lab, who helped get the real-time demo working. So it's a big team, and I really appreciate the honor.
Thank you, Mark. Wonderful. Okay, so now I'll just remind everybody here in this community that you can submit your project from your group or from your individual PhD project. You are eligible to submit a MECA project within a year of finishing the PhD, the actual graduation date on your PhD. And there's many possible candidates here for these awards. So take a look at the rules. And now I'd like to give the floor to Terry and to Andre as chairs of the respective juries and any other jury members to say a few words also how they view this award. If you don't mind, Terry, to spring this on you. And now, jury, please come back on screen. Yeah, and everybody.
So I was back in the 1990s, but actually it was 1990. I did a sabbatical at Caltech. It was a wonderful opportunity to get to know the faculty. And I went to labbings at Carverland and got to know Misha, Toby, it was just a wonderful group that was creating this whole new field. But then Carver decided that he was going to retire, and we went into shock. Well, not quite, but we wanted to carry it on. And so we had a meeting at Idlewild, and a lot of the people here were there. Okay, Toby was there. Anybody else in the room? She was there, yes, okay. And, Rodney. Who's that?
Rodney, of course.
Rodney, of course, yeah. Rodney is here. But more people? Okay. But what was wonderful is up in the mountains outside of San Diego, and it was really just beginning to think about where we could go as a group, what we could do. And it was just the address event idea of chips communicating was just, Misha was involved in that. Yeah. Very, very, very nascent. And we were all younger. and there's a video of this, and you didn't play it. Yeah. But because it's just the people who were there and talking, about what they wanted to do. And it was from there that we went to Washington. I mentioned this. For a workshop that we organized, and from that came the first grant from NSF. And this is the longest running workshop that NSF has ever funded for it's continued for 30 years plus. Now, the thing about Misha was that not only did she do this amazing work with Carver, but she was a biology major as an undergraduate, and this is something that Toby mentioned, but it really is a jump, right, to go from biology to neuromorphic engineering. But she brought an insight because of her background in biology. And that's really what makes, I think, this field special, is that you're trying to blend biology with engineering. And now I think the time has come. And I think these awards are really a reflection of the energy and the directions that things are going. And it's not just chips, right? I mean, the chips are important, but it's using the chips and using other computational approaches that are inspired by neuromorphic engineering to solve complex problems in the real world. And our time has come, because it's pretty clear that we can't go on forever building $100 billion data centers for AI. It's just not going to happen. And so it's going to, at some point, it's all going to have to be miniaturized, and it's going to have to be implemented for edge devices. And that's really what you guys are really in a position to do. And you should be able to take advantage of that. And I found out that there are now a lot of startups, aren't there? There's neuromorphic startups.
No, there's no reason every home can't have a brain, and your house can be smart.
Okay, well,
Well, there's one in the house in my house. Mine is a half.
well, why stop with your house? I mean, every device, every appliance should be able. You should be able to talk to it, and it should be able to talk to you, right? Okay. Well, in any case, I want to congratulate the winner and really.
I would also like to give an opportunity to Rodney, Kynan, Steve, and Andre. Is Andre still there? Especially Andre, as the chair of the MECA jury, or MRE. Also, you're part of the deliberations. I'd like to say a few words about the prize or how you see it moving forward in the future.
Yes, please. Thank you, Toby. Congratulations to both the winners, Jens and Mark. We were very delighted this year to see a large number of applications, and hence we ended up with 2 winners this year. We've had other years where we couldn't decide on a single winner, often not because the work wasn't good enough, but these are individual awards coming out of your PhD, and it's important to motivate when you apply for these why this is relevant to neuromorphic engineering and why this is a good project, but also why this is you that should get the award for it. And that was done much better this year too. And I think part of this has been us as a panel and the awarding organization educating people about what we expect to see in these applications as well. So I hope that from now on we won't have any issues anymore with not being able to award this, and we hope we see many applicants again in the future for the next year's award. So thank you.
Okay, thank you, Andre. And Rodney, as the one who really conceived this award in the first place, and was there since the very beginning, do you have any words about it?
Well, actually, I'd like to yield my time to Kynan, whom I recently heard give a very good summary of neuromorphic startups and the problems of or promises of neuromorphic engineering over the next couple of years. Kynan, could you put that together again in very quickly?
Okay. Yeah, so Toby, Rodney, and I conceived this award. I remember we were sitting at INI and trying to think, okay, we want to try and push the field, right? Try and create a competition where people enter and maybe get upset if they don't win. And it took a little while actually before we realized we should name it after the obvious choice, which was Misha. We've been at this for 10 years now, and I'd like to very much thank the jury, many of whom have served with us from the beginning, right? These people are extremely busy, to say the least. And I think it's a great sign of the regard that all of our jury members have for the field, and Misha, of course, that they're willing to volunteer their time year after year to pick out the best of what comes out of this field. So thanks a lot to all of the jury members.
Yes.
Rodney, do you want to say something else?
Oh, no, actually, in addition to that, Kynan, thank you very much. But in addition to that, at this recent meeting that we held at the Collegium Helveticum, you had this scaling argument for why it is that we should be taking the future of neuromorphic engineering seriously. And I think that this is a good venue just to rehearse that, if you can recall.
To be honest, I actually can't recall what I said. Maybe you can recap what I said, because I honestly don't remember.
You just made the point of the typical size of a piece of equipment over the last decades, and what that means for neuromorphic engineering, in the sense that we always thought of computers as being kind of, first of all, large computers in a room, then a laptop on a desk, then a PDA in your hand, now probably something on your glasses, and in a decade from then something in your head. And this is really, I thought, a simple but very compelling summary. And when you get down to those kinds of volumes and masses, there are going to be very few ways that you can do that and also interface with brain. So yes, there are many opportunities, and I thought that that was a point that you made better than I have now. But
Thank you, Ronnie. Wonderful. Thanks again to all of you. Okay, so that's it for now, and thanks to all of you, ladies and gentlemen, for your attention. And now it's time for lunch, I guess, and working on the project furiously to get the demos ready.